Ayubowan. May you have a long life. I am Dr. Samanthi Konarasinghe from Institute of Mathematics and Management, Sri Lanka. Today, I am going to talk about the problem-based learning in mathematics. First, we'll see what is problem-based learning, or PBL. PBL is a teaching method in which real-world problems are used as the vehicle to promote student learning of concept and principles, as opposed to the direct presentation of facts and concepts. In other words, problem-based learning is not like the memory-based learning. In memory-based learning, what we do is the teacher is teaching and the students are copying or understanding or whatever. But in problem-based learning, the students are actively participated in the learning process. So the problem-based learning is a student-centered approach. The traditional method of teaching is the teacher-centered, but the PBL, it is student-centered. In PBL, generally, it's a collaborative work. Some work or some task is assigned to small groups, typically 5 to 10 students related to the real-world problem, and assign that to students to find solutions and suggestions. Before moving any further, we'll see the history of problem-based learning, how it was begun. The pioneers of problem-based learning are Howard S. Burroughs and Tamblyn, Robin M. Tamblyn. Both are scientists or the academicians from McMaster University in Hamilton, Canada. They first introduced this problem-based learning methodology in 1960s. This was introduced for medical students. Problem-based learning, as the pioneers say, it is not a new concept. According to them, problem-based learning is the basic human learning process that allowed primitive man to survive in his environment. So though we talk it as a new thing, indeed it is the oldest learning method, problem-based learning. How? At the beginning, from the beginning of the society, the people have problems. So finding solutions for them is the way of learning. Say for example, food storage. For rainy season, they wanted to store food. For drought, they wanted to store water. So that was a real world problem. They started thinking about it. They had a problem, they started thinking about and found out solutions. So that was the beginning of the problem-based learning. As this Burroughs and Tamblyn says, sometimes we are not aware that we are in the problem-based learning process. So for example, you drive your vehicle. So all of a sudden you get a tire punch. Up to that point, you are not aware how to change the tire. But now, if there is no one to help you for changing the tire, then you have to do it. So there is a problem. It happened for you to start learning that. So that is what the problem-based learning. Until that point, you never wanted to know how to change the tire. But now there is a need, so you start thinking and then somehow or the other way, you try in various ways and get it done. But from that point onwards, you have that knowledge. That knowledge remains in your brain. When the second time a similar thing happens, you don't get panic. Why? You know how to do it. You have done it earlier. That knowledge is in your mind. Even if you follow a course how to maintain your vehicle. So even if you attend so many lectures, even if you do practical of course something will remain in the mind, but lectures will never. But with this problem, because you are panic and you are helpless, now you found the solution, that knowledge will remain. So that is problem-based learning. Working towards the problem with a specific goal, with a reason. So as Barrows and Tamblyn says, it is the learning that results from the process of working toward the understanding or the solution of a problem. So the problem is encountered first in the learning process. We start the process with the problem. In PBL, Barrows and Tamblyn, they address some basic ideas. Actually, as I said earlier, this was introduced for medical sciences, biomedical sciences, medicine, and other health sciences. What their idea was this: you know, a medical degree, it is a practitioner degree. In medical colleges, all over the world, in medical colleges, first 2 or 3 years, students learn the theory, only the lectures. They have lab practice, lab experiments, but no clinical trials. So they learn theory for 2 or 3 years, and then only they go to the wards. Then only they meet patients, start taking history from the patients. So these two scientists, Barrows and Tamblyn, as medical practitioners, they have realized that this is not a good method for teaching medicine or biomedical sciences or health sciences. Their fundamental ideas were learning through problem solving is much more effective for creating knowledge, and physician skills most important for patients are problem solving skill, not memory skills. By memorizing all the things in medicine, they realize that they cannot create a good medical practitioner. So the student should go to the patients and understand the concepts. So with that, they make small groups of 5 to 10 students and assign some tasks in wards. Maybe there is a patient, the lecturer is aware that the patient is having a cancer, but without saying anything, the group is assigned this task: find the problem and the other symptoms and everything. So the students were assigned the task without teaching anything. They are given some time, and later they were supposed to present it. So that way the student learn a lot than the primitive lecturing method. So that's how Barrows and Tamblyn introduced this problem-based learning technique. Let's look at the differences between memory-based and problem-based learning. In traditional method or the memory-based method, students learn about information. That means the teacher or lecturer teach theories and methodologies. So the students try to understand, memorize, and apply them in real life situations sometimes, very rarely actually, and more than that, memorize them and write the answers to the exam. That is the traditional teaching method. So one advantage of this traditional teaching method is only one facilitator, one teacher or one lecturer is needed for a large group. You know, in universities, sometimes for one lecture we have 200, 300 students. So only one lecturer. Then not much resources are needed. They are in a lecture room. The lecturer come to the hall and start teaching. So I really don't know, but that would have been the reason for this memory-based learning practice came into action in education system. When it comes to problem-based learning, it is student-centered approach. So the lecturer or teacher has to prepare first. That is one problem in problem-based learning. Like the lecturer has to prepare a task and have to provide necessary equipments. Maybe if it is biological science or chemistry or whatever the thing. So the lecturer or teacher has to provide necessary equipments to the students and make sure their safety. If they are conducting a lab experiment without the prior knowledge about the chemicals, it is dangerous. So the lecturer has to make sure they are not in danger and make them understand. So the problem-based inquiry, as I said earlier, true, they learn a lot and it is very interesting. You know, in a lecture, traditional classroom method, it's quite a boring job. Most of the time, students do not listen to the lecturer. But it doesn't happen in problem-based learning because they are actively participated and they have some power. They are the decision makers. So their creativity comes up and they learn the methods. So this way, the students will get interest about the subject. Those are the basic differences about the memory-based and problem-based learning. When designing a problem-based learning technique, that means when applying the PBL in classroom or lecture room, the facilitator first has to identify a real-world problem. Say you are going to teach something related to your topic. Related to your topic, in your mind, you have to identify real-world problem or problems actually. Then you have to make some activity. Keep your objective in mind, develop some activities, and then create and distribute helpful materials to the students. Clearly set the goals and expectations for students. You are supposed to do this. You are supposed to talk to 10 of the neighbors. You are supposed to collect the different colored of flowers. Something like that. Otherwise they will go wild. They don't know really what you want to do. So you have to give set goals and a real expectation. That means expectation is what they are supposed to present, what they have to bring, and then make them participate. So you have to be with the students. You have to see whether the things are going on correct way. Not as a supervisor, just to watch. So you are a part of them. You are not going to control them. Later, when it is done, make students to present their ideas and findings. That is the way of conducting a PBL in classroom. Problem-based learning method is getting more and more popular. It has advantages as well as disadvantages. What are they? It has many benefits. As we already discussed, it develops long-term knowledge retention, uses diverse teaching and assessment methods, increase student continuous engagement, development of transferable skills including teamwork and research skills. They are benefits. This research skill, you know, at undergraduate level or postgraduate level or as a senior researcher, conducting a research, it is a problem base. Because to conduct a research we have to identify a research problem. It doesn't come automatically, but we somehow or the other way we find a research problem. We say it is a knowledge gap. Without a knowledge gap, we can't conduct a research. So we find a research problem and start our research. Maybe it can be your master's degree or PhD or after that. So then, for us, it was quite difficult when we were doing PhD or when we were doing our master's degree. Finding the research problem was the real problem. Why? We were in traditional classroom. We learn memory base. We are the product of memory base. So we are not used to open our eyes to the real world. But in contrast, if the problem-based learning technique is adopted in school education and the university education, then research will not be a difficult thing for students. That is one major benefit of problem-based learning. However, there are certain challenges. It has been found that after this problem-based learning, when they sit for the test or exam, their performances are poor. And they do not prepare much, because before the lesson, there is no preparation, no prerequisite knowledge. They are not familiar with the terms and things. As I said earlier, this PBL method was introduced for medical students. So the applicability of the problem-based learning method is not same in all the areas. After the medical sciences, even the other areas of studies have been practicing this one over the years. However, applying them in your classroom is different from the medical school. Now I am going to talk about the applicability of PBL in mathematics. That is my area of study, my area of teaching. Mathematics, you know, it is not a subject actually, it is a language. Why? Mathematics is used to understand all the other subjects. Therefore, it is known as a subject of instruction. It is believed that, actually it has been proven that mathematics develops so many skills of the students: critical thinking, logical reasoning, problem solving, time management, and so many other skills. You know, from the primary school, mathematics is given higher weight. Everyone is so much concerned about mathematics knowledge. Due to these reasons, it helps improving so many skills and to understand other subjects. Mathematics plays a crucial role in all the other disciplines: mathematical physics, chemistry, medicine and biology, finance, econ, then business, engineering, computer science, social science. There is no field in this world where mathematics is not applied. In short, research, scientific research, is based on mathematical modeling. Therefore, all the disciplines are related to mathematics. Hence, problem-based learning application in mathematics is very important. If you look at the history of mathematics, we can understand that it also began with problem-based learning. According to the history of mathematics, the first Babylonian and Egyptian, they were the first people introduced mathematics. Mathematics as a demonstrative discipline begins in 6th century BC with Pythagoreanism. Pythagoreanism. We all have learned Pythagoras theorem at some place in our school's education. Secondary school education, we all have learned Pythagoras theorem. As I remember, that was the first theorem I have learned. So these Pythagorean triples are shown in Babylonian and Egyptian texts. So they were shown in clay tablets. Here are the clay tablets. You can see those triangles are drawn on these clay tablets. Imagine, why did Pythagoras and his fellows wanted to think about the triangles? Right angle triangles. Definitely, they have observed right angle triangles and other triangles in the real life. Maybe they had some problems related to these things. Therefore, they started thinking about them like this. Look at these diagrams. Pythagoras theorem, which we learn in school, is applicable in these problem solving. So that would have been the beginning of, or the originate of, Pythagoras theorem. To rescue this man, need to know the length of the ladder or where to keep it, and even to make a kite with the bamboo strips, the length of the two sides and the hypotenuse. With experience, we can understand the ratios of these lengths and the relationship between them. This aeroplane landing, what is the distance simple c to be traveled up to the runway when the height is 5.2 kilometers and distance to the horizontal distance to the runway is 10.2 kilometers. So these are real life situations, real life problems. You know, in research, there are two types, pure research and applied research. All the pure research started with real world problem. They all are problem-based learning. A well-known example, Sir Isaac Newton finding the gravity law. He observed apple falling. He started thinking why this apple is coming down without going up or sideways. See, started from the real world problem. Didn't know anything about it. So after some times, he come out with a new theory. That is problem-based learning. Then we can understand that the problem-based learning application in mathematics is begun with mathematics. Otherwise, there was no reason to develop these mathematical techniques. I will show you one example of memory-based and problem-based learning in mathematics. You also have this experience. In school, we all learn functions. I'm sure you can't remember these equations, but you can remember these graphs. Linear function, quadratic function. So though we learn, we really didn't know why we learned these things. We did the exams, we passed the exam, but we really didn't know why we learned them. See this. If using the problem-based approach, constant polynomial function and the brick wall are related. Constructing a brick wall, layer by layer, brick wall is going up as set of constant polynomials. And the staircase, it shows a linear function with positive or negative gradient. Quadratic functions. See, in how many places we can see quadratic functions in real life? They are all around. When teaching functions, if we take these examples or if we make students to find these examples, first introduce the theory part, then make them find these examples, or the other way around, that will make sense. Another thing, exponential functions. As researchers and even in day-to-day life, we use exponential functions. Only thing is we don't know that. Say when you are sick, you go to the doctor and you say I have a fever, and the doctor will, the medical practitioner will check you, and asks you to take two paracetamol tablets in every 6 hours. How does he know that you have to take in every 6 hours? That is, again, functions. Initially, when you are taking the first two, its concentration is at the highest level, and gradually it is decreasing this way. The concentration of the vitamin or the medicine leaves the body this way. It doesn't come to zero, it almost come to zero, so it is exponential function. If you deposit money under the compound interest, it will grow with exponential. When you buy a car, its value depreciates, that is exponential function. So these are applications, real life situations. When teaching these things, we can incorporate our lessons to these examples. Another thing, trigonometric functions. You all have learned sine, cosine and tan in school. But I don't know whether you have learned any of the real life applications. To find the depth of the water or to explain any wave-like patterns, maybe the music notes or the pulse rates, blood sugar levels of a patient. So all these things are related to trigonometric functions. Reflection. You know, another important thing is transformation, highly applied in statistics as well. Transformations. One type of transformation is reflection. Have you ever thought this stethoscope? Inside this rubber tube, large number of reflections are happening. So that is mathematics. And the periscope. So all these things are applications in real life. What I wanted to tell you is problem-based learning is a really good method. It is old as the world. From the beginning of the world, people have problems. Therefore, they start thinking and solving them. Problem-based learning as a technique in education was introduced in medical sciences. So the case studies, activities are there, activity-based learning. So the same is not applicable in all the areas at the same degree. If I think about mathematics, mathematics is like a huge tree. It has so many branches. Numerical analysis, linear algebra, cryptography, game theory, applied maths, differential equation, and so many things. For some of these branches, of course, no teacher or lecturer can make activities. That's impossible. Something like numerical analysis or the graph theory. Graph theory, of course, we can, but numerical analysis, linear algebra, it's quite difficult to make activities. But what we can do is, according to my understanding, for mathematics, mixed method is the best. Problem-based plus memory-based. Not exactly problem-based. We can combine them. So for your field of study, for your field of teaching, you should think about a suitable way. Blindly we can't adopt a method. If I start making activities for all these branches, that will never happen. Same is true for your fields of studies. Therefore, I suggest to introduce a mixed method, problem-based plus memory-based. But for certain areas, of course, the problem-based learning technique will be exactly fit. So, we have to use a Institute of Mathematics and Management believe this: practice makes perfect. To apply the problem-based learning technique, we have to first practice it. We have to think about the ways of improving it, and then only we can achieve our target. I would like to thank Dr. Flora Charles and the Eurasia team for giving me this opportunity, and thank you for listening to me. Have a good day.